We're going to chat on page 7, systems with 3 variables, but I want to do number 2. There's a reason for it, and I don't have a calculator. That wasn't a good start. So number 2 is a little bit different in that instead of having every single value there, it looks like our matrix would have to be a different size. Because you're like, wait a minute, the last 2 equations have 3 variables, but the one above it only has 2. What the heck is going on here? Well, let me tell you what the heck is going on here. I see x, I see z in the first equation. What variable's missing? Y. So this is really 3x plus 0y plus 2z equals 23. If there's a missing variable, you have to replace it with 0. You can't just skip over it. That won't work. And so once we've got that under control, the other ones are good. They have values. We're okay. So what we're going to do, like I said, one more time, just for fun and giggles here. Let me get this up where we can actually see all the buttons. Second, x negative 1. Bless you. We hope once we arrow over to edit and hit enter that the matrix there is already 3 by 4. Now with me having 2 classes that did this yesterday, I'm thinking your odds are pretty good. But if they're not, okay, if it's any other numbers, just to play it safe, hit 3 and hit enter, hit 4 and hit enter, and your matrix should get to the size that you need it, which is this one that you see on the screen right now. Once I'm sure I'm good, let me move this down so I can actually see my values. We're just going to start, and as we punch in each number, we're going to hit enter, and that's going to keep moving us throughout our matrix. And when we get to the next line, it automatically puts us there. Only the numbers in front. We don't care about variables. And if I've done everything correctly, when I punch in that last number, that -5, it should go back to the beginning. So that was actually the longest part of this whole thing. Once we do that, we must leave the matrix for a moment. So to quit, we're going to do second in mode, clears things out, and we jump right back in. Second, x negative 1, arrow over to math, arrow down to B. Make sure again it's R ref, not just ref. Those are different. Hit enter. Last steps. Second, x negative 1. 1 enter to say that's the matrix we're plugging in. 2 to get the answer that we're looking for. And so when this matrix shows up, and I'm just going to copy it down here. We're going to simplify a little bit from what we said yesterday. Basically, even though it is x, y, z, and equals, for your purposes, let's be honest, it's x equals 5. It's y equals 0. It's z equals 4. I'm done. Okay, the calculator does all the work. I just punch in the values. So like I'd put on the screen when we first came in, I'd said try 3. Well, I just did one of them. Make sure you get a couple more of these in, because that's easy questions on the test if you just know how to use the help sheet and work it through. Not going to be bad otherwise. Okay, but the main event of today and tomorrow is not on this page. Oh no. The main event for the next couple of days, and as I always say on previews, if you're feeling good that you can do it on your own, I say go for it. Okay, the key is up, so you can kind of check it as you go. And so here on the preview, sketch the graph of the line. Okay, let's see here. Quick reminders. And this is all stuff that you have in your notes already. So if your notes are updated, you don't have to put all this down, but maybe for convenience you do. I don't know. M is our slope. B is our y-intercept, and we always do that first. So in me sticking with saying I'm doing odds, which I will. So I look at the first one, we're in y equals. Hallelujah, we don't have to do anything else. There's my y-intercept of 3. My slope always should be a fraction. If it's not, just put it over 1. But here's where we're going to run into our first issue. If my slope's 5 over 1, I'm supposed to go up 5 and right 1. Well, I can't. 1, 2, 3. Uh-oh, I ran out of room. Well, crap. Remember, you always have the option, if you run out of room, of changing both of the signs, which now would make this become 5 down. 1, 2, 3, 4, 5. Hey, I can do that. And 1 left. Can I do it? 1, 2, 3, 4. I'm going to wing it. 5 and 1 left. Put that in there and go. Okay, but it's always going to be the same order with those. That is not going to change. But what might change is what happens in number 3. Uh-oh. Uh-oh, can I get it on there? I can see it a little bit here at the start. That's not in y equals right now. That's got to get fixed. So here, I need to get that positive 2x to the other side of the equation. So I got to do an opposite. And since we want it in y equals mx plus b, we got to put the x term first. So that's the equation I'm going to be working with. So I get here and I'm like, all right, there's my y-intercept, always on the y-axis, -4. My slope, down 2 and right 1. Alrighty, can I get away with 2 dots? If you're feeling lucky, yeah, you could. But again, if you're not feeling as lucky, that -2 over 1, again, you'd switch the signs on both. So negative becomes positive, positive becomes negative, and I'd go up 2 and left 1. Now I'm really sure I did this right. So sometimes we got to get y by itself, sometimes it's ready, but either way, we got to get that y-intercept and the slope working here, or things get a little bit ugly sometimes. So I'm peeking. I'm trying to peek ahead and get a preview of what I'm seeing. Okay. And again, I'm recording everything that we're doing. So if I'm going to change something on the fly here. Already, why you changing stuff? Because it's better to change stuff. So we're changing on the fly. We're going to do... All right, problem change on the fly for number 5. Why did I do that? Because standard form, when you're doing it, so x and y have to be on the same side of the equation, and a has to be positive, and you can't have fractions. Again, that's all in the notes, though. That's all in the notes. So my first job, I guess, is I want to get my x and my y together on the same side. So I could do it either way, but I notice right away that my x is negative. So it might make it a little better to just move that to the other side and make it positive. And I notice something when I do that. X and y are on the same side, check. My a value, my number in front of x is positive, check. And the plain old numbers on the other side. Hot dog. That took one whole step. That wasn't bad. So that's the type of thing that we're looking for, though. We got to keep an eye on those two things, though. Again, good to have your notes, and also good maybe to kind of check your notes versus this review, because you never know, the review and the test might be in the same order. Not saying, just saying. Okay. Our equations. Write the slope-intercept form. Okay, y equals mx plus b. We were doing that to graph. Of the equation line through the given point with the given slope. Okay. So there's two ways I could actually do this. So they told me the slope. Okay, so I got that part. For me to get the equation, I got to get both of these. So here's one way you can go about it. We could use point slope form. This is what we did do when we did this lesson. This is one-stop shopping where I can get everything done at once. So these 2 points are x1 and y1. And so what we're going to do then is we're going to take those and we're going to plug them in where the arrows are at. So I start to write, and I'm like y minus, okay, y1 is -3. We'll deal with that in a minute. Equals. My slope, my m is 2. X minus x1, which is -4. Now, I'm not a big fan of looking at all those negatives and stuff there. So we do know already that minus a negative is positive. So I'm just going to make this stuff plus to make it a little bit cleaner. And I also know at this point, whenever there's parentheses, we're going to have to distribute. And this is why I always say it and say it and say it. Show me all of your work when you're going along. Because let's say here you put -4 instead of +4. I mean, you did everything else right. You're getting the majority of the points. If you just like throw down nothing or just stop there, then we don't get there. The goal, get y alone. Because we want this. One last step. Once we get it into the form, it does not take long to get where we need to be. But again, label your stuff and know where these different forms are at in your note packet. The only difference between these two and these two is this time I got to find the slope too. So, okay, when I'm looking for slope, okay, there's my slope formula. So when I'm trying to do these, we get those in. So my first job, I have several jobs this time. My first job is to find the slope. So we're going to do y2 minus y1. And we're going to do x2 minus x1. And just like we saw up above, and maybe you see this right away and don't even get into this situation, minus a negative is going to become plus. So we got 5. And the same thing happens down below. We get 5. So I've got my slope. I'm halfway home because all I need now is my intercept. So to get that, we're going to pick one of the 2 points above. It does not matter which one you pick. I love zeros, so I'm going to use 0, 0. And we're basically going to do this. So I get down here and I'm like, all right, so y minus, my y value is 0. equals my m x minus, and my x value is also 0. I know it seems strange that I'd get the same answer if I used the -5 in both, but I really would. So I do a little to show y minus 0. That's nice. So either one of those, since when I distribute I get 0. Oh, push up Hardy so they can see. So even if, let's say you roll on the test and all of a sudden you're like, I can find the slope, and then you forget about the other form. At least show me the slope. Okay, again, show me what you can. We'll get some points and we'll get it working for you that way. That was probably the most work we've got for the rest of the sheet here. We're a little over halfway home today. Find the slope of a line parallel. Parallel means the same slope. But you've got to be in y equals before you can do that. That's the I'll swear that is the biggest thing on this entire test that you're going to see. If you can keep getting equations into y equals form and do it cleanly, now this is going to get a little goofy though. So I get to this point and I'm like, okay, so now what? Well, I got to divide everything by -8. So those go away. Let me grab this quick. 9 divided by 8. We don't do decimals there. Okay, 9 over 8. And then 40 divided by -8 is -5. So do I just circle that and I'm done? No. What would the slope of the other line be? Let me know that you know what you're looking for. Whatever that value in front of x is, you're just copying it. You're saying, hey, the other line may have a slope of 9/8 too, and I'm done. Now, if you get to the equation and you stop, will you get dinged a little? Yes, but not very much. But again, it's understanding what the question happens to be asking. Now, and if I need to rewind later to any of these things, I can do that too. Okay, one more thing with slopes. Then we're done with slopes for a bit. Perpendicular. When it's perpendicular, that is the opposite reciprocal. Now, in normal terms, that means we're going to change the sign and we're going to flip it. So, Hardy, couldn't you at least just give us this in y equals already, for the love, dude? Well, my idea is if I make the questions on the preview, I make you do more, and then I get to the test, and I don't make you do as much, I'm going to have you over-prepared, which I'm willing to take that chance. So I got to get y by itself. And again, this comes back to practice and seeing things so we don't make silly boo-boos. Like thinking we need to add 3. Don't want to add 3. So negative divided by negative is positive 1/3. 3 divided by -3 is -1. But now, there's the slope of my actual equation. I want the opposite, which would be negative, because that's positive, and I want that flipped. That's what we're looking for. What's the slope of your new equation if we were to make one? Flip it, change the sign, go about your business. Almost there, people. Because I think I'd said I was going to make it to 12. Yup. Going odds, we're doing pretty good, actually. Sketch the graph of the linear inequality. Okay, we're going to graph it like a line with 2 exceptions. So, let's graph it like a line first. Y-intercept, there's my 1. My slope is positive 5 over 3. 1, 2, 3, 4, 5. 1, 2, 3. Or, if I want one more dot, and I do, I can do the opposite of both. 1, 2, 3, 4, 5. 1, 2, 3. Now, before you draw a line through it, we got to pay attention to a couple of little details here. That less than arrow is actually going to help me with two things. Number one, it tells me my line itself is dotted. If it had a line under it, it would be solid. So we got that taken care of. And then it also tells me which side to shade on. Since y is less than, when the arrow points at y, we're going to shade under the line. If it's eating y, we're shading over it. And again, all in your notes. There's the underside. And I'm done. Cannot just graph the line. I mean, if you did just graph a line, I'd give you a point for graphing the line, but you wouldn't get the inequality parts, and that's going to be a couple more points. So I said, this is a chunky review because we've done a lot of stuff for this part that we've gotten through here. Okay, last piece from Hardy today, if I can turn the page. We'll save the heavy-duty equation stuff for tomorrow. So I get one more graph here. If I don't see an intercept at the end, it's going to be at 0. And just a reminder when you're doing slope, if it's negative, it means it's negative on one number, and one number only, not both. Either one's fine, though. So I could go 1 down and 4 right. Put a dot, and of course we're out of room. Or I could switch the negative and go 1 up and 4 left. And then here we go with all the line shenanigans and the shading again. Greater than or equal to solid line. Y is greater than or equal to, the arrow is eating y, so we're going to shade above it. Only got to do the shading when there's arrows, though, not equal signs. And then since we've been graphing, we'll finish with graphing. Solve your system by graphing. We're looking for where they intersect, and so it's going to be really important that we put every dot that we can for this. So one last move from me, and then like I said, if I need to put a different part back up, I will. I will have colors available when we get to the test here. Here's my y-intercept. My slope is negative 2 over 1. Down 2, right 1, down 2, right 1, down 2. Hardy, can I stop? I wouldn't. I still got half a graph I can graph on. Up 2, left 1, up 2, left 1. These are just equals. We're just connecting the dots. And now we hope when we graph this other one, we're going to have a dot in common. That's the goal. Up 2 and over 1. That's what I'm talking about. Up 2. All right, Hardy, we already see where they cross. I do. Right there. But don't just circle it. I need to know where that is. I went right 1, positive 1 on the x-axis, and I went down 1, negative 1 on the y-axis. Okay? That's the first half of the things that we're doing for this test. So again, play with the odds. No, the odds. We just did the odds. Play with the evens up to 20. You've got a direct example to work with, but I would suggest, I mentioned it earlier, find these different sections in your notes so you know where to look when you get to the test. So you're not spending all this time looking all over for something that you don't even know where it's at.